Okay, I think we're live. Okay, cool. All right, so questions. Costco, get us started. 44. Oh, by the way, if there was ever a thing that I would like you guys to actually pay close attention to, 22 through 31, just make a note of those. 22 through 31, those problems are a lot more involved than you would give them credit for. Okay, they're really involved, like deceptively uninvolved looking, right? But they're actually very involved. So if you have questions from those, I would very much appreciate those. That way we can go over them. And then so Costco, you said 44? Got it. So with 44 here, all right, so it goes 8i, parentheses, 3 plus I, and then parentheses 2i. Now, the most important thing about this problem, 44, as well as 45, is the notion that the order of multiplication doesn't matter in the sense you can reorganize it, but it does matter in how you efficiently solve this problem or simplify this problem. So Minu, here's what I'm not going to do. I am not going to distribute that in. I'm not going to do that. And not that there's anything wrong with it, but instead I'm going to multiply these two together. It's just going to make my life easier. Okay. The reason why it makes my life easier is because now 8 times 2 is 16. I times I is I squared. And we all know what I squared is, right? -1. So this thing becomes -1 times 16. Can we all see that okay? So I get -16 times 3 plus I. So Minu, you see how that's way easier to deal with than distributing and then redistributing? That would have actually really sucked. So now I get -48 minus 16i, and I wrap up shop. Good enough? Next question, please. Sarah, talk to me. 28 and 20. Okay, great. So again, a lot more involved, right? So 28. So it says rewrite in simplified radical form. Now, some of these are going to simplify all the way to the point where there is no more radical involved. So in my opinion, Sarah, some of these you might want to just convert and then simplify it however you want. This one is a case in point example. The fact that there's a negative exponent there, hopefully from integrated 1, we remember this. If I have 8 to the -2/3, the negative, all it does is it shifts the thing down to the bottom. So you okay with that? So now from here, technically, if I wanted to write this as a radical, it would be the cube root, because the cube is on bottom, of 8 squared. And that would be the simple, this would be the radical form. This would be part of it, but it's not totally simplified just yet. You okay? So at this point, if I was going to simplify it, I'd actually use this version. This version seems easier because I'm going to take the cube root of the 8. Anyone happen to remember what the cube root of 8 is going to be, Landon? 2. So what I've got is 1 over 2 squared. And then can someone finish off this problem? 2 squared is, Jensen? 1/4. And that would be my total simplified answer. So I would take both of these. You do. You do, yeah. Yeah. Jaden, what's up? 1 from the packet. Okay, new question. Oh, I'm sorry. Sorry, you said 29 first, right? Okay. I just did 29. Sorry about that. And I'll go and do 28. You tell me. Shouldn't the packet be in front of you? Yeah. 27 to the -1/3. Okay, cool. So Sarah, again, negative exponent, bust them to the bottom. So 1 over 27 to the +1/3 now. So again, the radical form would be the cube root of 27. That would just be the radical form of it. But I think we know what the cube root of 27 is. Anyone happen to be able to tell us? Kind of? 3. So this would be your final answer, Sarah. It does say simplified radical form, so I would say a radical does need to show up at some point. Jackson, what's up, man? 40. Sure. Can I hit 1 first from Jaden? Okay, number 1. Oh, crap. Number 1. So it's a triangle here. So this is an F, this is a G, this is a 6, and this is a 30. Okay. 30, 60, 90 special right triangle. Okay. So from here, normally opposite the 30 is the shortest side, opposite the 60 is the medium side, and opposite the 90 is the longest side. Now, what is the piece normally attached to the medium side that strangely is not present right here? Jensen. Isabella. a root 3 is normally attached to the 6, but this time it's not, right? But is that wrong? No, it's just odd, right? And so how do I move from the medium side back to the small side, given the fact of how we move from the small side to the medium side? What do you think, Ava? Divide by rad 3, right? So I know that F is equal to 6 divided by rad 3 because we normally multiply by rad 3 to move from small to medium. You okay? Not done yet. We got to rationalize that denominator. Ava? Rad 3 over rad 3 on top and bottom. 6 rad 3 over 3. Goodbye. I'm getting 2 rad 3 as my value for F. Jaden, you okay? Because the 6 and the 3 divide each other out. I have 6 rad 3 over 3. So that gets me 6 rad 3 over 3 because the rads cancel each other out here. What's 6 divided by 3? Not the rads, the whole numbers do. Sure there is, because what happens is when I rationalize the denominator, right? 6 times rad 3 is 6 rad 3. Rad 3 times rad 3 is 3. So then the whole numbers, 6 divided by 3 becomes 2. So I get 2 rad 3. Now we're not done yet. Can someone tell us what G is going to equal? Zoe. So G is going to be 4 rad 3. Caleb, talk to me.
Is it okay if your answers are in decimal form and not rad form?
You know what? If I was a betting person, I would bet that this midterm is going to be non-calculator, which means there would be no avenue for you to have a decimal for a problem like this.
Okay. Also, could like we could do number 40 first, but like I was just gonna ask, could we please do number 30?
Sure. Let me hit Jackson first, and then we'll come back to Caleb. Nicole, talk to me.
Wait, can you explain one time how you went from how you found F?
Yeah, because on a 30, 60, 90 right triangle, right? The short side is always opposite the 30, right? So to move from the small side to the medium side, you multiply by rad 3, which means in order to move from medium back to small, does it make sense you would divide by rad 3 because it's the opposite operation? Because originally it began off as 6 over rad 3.
Why 6 over 3? Oh, because you're dividing. Is that like a self to self kind of thing?
Not exactly. It's just like a ratio kind of thing. Yeah.
Okay.
Yeah. Howard. Okay, you got one? All right, hold on to it. Jaden.
So if I were to go from in a 30, 60, 90, if I were to go from small to medium, multiply by rad 3?
That's right. And to go from medium to small, divide by rad 3. Yep.
Times 2 of the small.
There you go. There you go. All right, Jackson, ready to hit 40? Let's do it. 40. So from here, so guys, pay attention to the operation happening inside between the pieces. Don't add when you're supposed to multiply and all that mumbo jumbo. Here, I'm going to go ahead and multiply those guys together. Now the outside pieces will multiply. It'll become 8 rad 3. This time, the outside will stay on the outside, but the inside will stay on the inside. This will become 4 rad 7. Jackson, you okay so far? Then the inner piece, I'm going to get negative 14 rad. Now check it out. You see how they're both radicals? Rad 7 times rad 3 is going to be rad 21. And then the last one is going to become negative rad 49. How you doing so far? This 14 here? That would have been from 14 rad 21. That would actually be a mistake. 2 rad 21. Yeah, thank you. Yeah, sorry about that. Thank you. Cool. So now all we have to do is just do negative 7 right here because the square root of 49 is doable. Jackson, none of the rads are combinable by like terms, not even the 21 and the 7, because 21's has no perfect scores in it. So you just have to bring down what you don't use and then close up shop. As frustrating as that answer looks, that is your answer. Good enough? Howard. Oh, sorry, Caleb, sorry. What are we doing?
Number 30. please.
30.
I have a question on the
Landon, talk to me.
So would you just use FOIL basically?
Yes. Yeah.
What number is that?
This is number 40. Now, Landon, you could have also done the area model on that one as well. Yeah.
That'd be a little harder.
Yeah. Ava, what's up?
I just have one.
Different. Okay, so we'll go Caleb and then Howard and then Ava. Nicole, talk to me.
After that, can you also?
Okay, we're getting queued up on the questions here, so just hold on to it. Yeah. 16 to the negative 2/3. So Caleb, this is yours, right? Okay. So Caleb, this one here, put a star next to it. This is actually the most deceptive question. It's actually very much simplifiable, but not the way you would think. Ordinarily, you would think this would be 3/2 because it would be, you would be able to take the square root and then cube it. But in this case, all you can really do, Caleb, is you can just knock it down to the positive 2/3 power. You okay?
That's all you're able to do.
Well, with the knowledge you guys have right now, yes. However, this is what you are supposed to be able to do afterwards. Ava, what's up? No, actually, I would not put it in rad form just yet. Here's why. Because we're about to rationalize this denominator, but I'm going to multiply it by something you guys would never expect, all right? So I'm going to multiply it by something. Now, remember, the purpose of rationalizing a denominator is to get rid of the radical, right? The radical is technically the 3 portion. You guys okay with that? So I'm going to multiply by 16 up top and bottom. The question is 16 needs to be raised to what power so that I can successfully make this 16 a whole number? Who can raise it and tell us what power should I raise this 16 to? Jansen.
1/3.
1/3. Because from integrated 1, we learned that if we multiply the same bases, we add the exponents. So what is 16? What is 2/3 plus 1/3? Landon. Uno. 1 3/3. Is that very good? 16 to the 1/3 is now up top, but we're not done yet. Because now, who asked about the radical? Now we're going to change it to a radical now and go cube, crap, that's too big. Cube root of 16 over 16. Now, you would think that you're done, Landon. No, we've already rationalized that part. But can the cube root of 16 be broken down?
Yes.
Can it? The cube root of 16? Can someone think of 2 numbers where one's a perfect cube and one's not a perfect cube that multiply to 16? Ava? 8 and 2. So now we get 2 cube root of 2 over 16. Are we done?
No.
No. What can we do now? Ava? 1 over 8. So cube root of 2 over 8 actually is the answer. So a lot more involved than you would give it credit. This is the most. Zoe, do not cut her hair. Okay. With your finger scissors. Okay. Yeah. Now that's on the internet for all to hear. Yeah. Do not attempt to cut her hair. All right. Howard. I got cube root of 2 over 8.
Are you expecting us to put that down the midterm?
If I gave you this problem, Caleb,
It's
this
a bonus
would
question.
give you full credit. I don't know. Maybe I might ask you to go that far if I wanted to give you something a little extra.
And
Howard. 32, sure. Sarah, about this one.
Why did you multiply by 16 over 16 on this one, and when I asked you just what to put into that?
Because this one here, there's no way you can simplify the cube root of 16 squared like that. So what you have to do, so this thing, the bottom is going to have a radical no matter what. So this is the process of rationalizing the denominator. Yeah. Yeah, unlike yours, you actually could simplify into something clean off the cuff. So there was no need to rationalize anything. There was no radical remaining in any of your questions. Yeah, what's up, man? Second? But the cube root of 256 is going to be a little hard to find. You'd have to know your perfect cube is pretty high, right? It's not impossible, but you could do it that way too, yeah. Howard, we're doing 32. No, it's actually Howard Mandel. Oh, all that stuff's gone, Sarah. You know, Sarah, this is going to go up online, so you don't need to copy anything if you don't want to. Right. All right, guys. Let's pipe it on down. Gael, talking to you. Okay. All right. So the square root of negative 72. Check it out. We are going to take the square root of a negative number. What needs to pop out this time? Kendall.
-1 and I.
An I, right? So it's going to be root 72 times root -1. This is going to be I. Now, two numbers that multiply to 72. I want the goodest combination. Pranay. 36 and 2. So this guy becomes 6. Don't forget the I. Rad 2. Done.
Right.
Yeah, kill.
Like, I thought you were supposed to like divide it in the three, then square root of -1, then the square root of 9 and square root of 8.
There's nothing wrong with that. If you do the square root of 9 times the square root of 8, you'll end up with this guy becoming a 3 and this guy becoming rad 8. But rad 8 can be simplified again into 4 and 2. So this guy becomes a 2, interacts with a 3, 6, rad 2. Either way you cut it. So you just didn't go far enough. Costco, talk to me.
Never mind. I have a new question.
Yeah, talk to me.
Oh, okay. Can we do number 52?
52, sure. All right, 52. Okay, for the following polygons, determine the number of sides the polygon has. So an exterior angle of a regular polygon measures 20 degrees. Okay, cool. So from here, the fact that it's a regular polygon probably is important, right? So the exterior angle is 20 degrees. So what's that formula for finding the exterior angle, like the single exterior angle of a regular polygon? What's that formula again, Jansen?
360 over n.
360 over n, right? 360 over n, right? Where n, what does n equal again? I apologize. I forget. Kendall?
Number of sides.
Number of sides. So from here, this is the number of sides, which is what we're trying to find, right? And the result of 360 over n gives us the answer of one of the angles. So what am I supposed to put after the equal sign? 20, because I know that each exterior angle is 20 degrees. So from here, boom, kick that dude over. 360 equals 20n. Divide by 20, I get n equals, is that 18?
Yes.
18-sided polygon. Who asked for this one? Minnie, are you good?
Yep.
Cool. Costco just released their new coupon book yesterday. Yeah. Yeah. The jalapeno chicken meatballs are on sale. Those are good, actually. Yeah. Jansen, you've been waiting.
Okay, so these are kind of all related. It's 12, 15.
12, 15, and 18. You didn't ask for those, right, Jansen? You didn't ask. Yeah. You never asked for those, Jansen? Okay, cool. Anybody who
I
plays.
think they're easy. I'm just like easy.
Yeah, no, anybody who plays Deus Ex Human Revolution will understand that reference right there. So it's a video game. Okay. So 12, you said 15 and 16?
12, 15, and 18.
12, 15, and 18. So 15 is tan 60. And 18 is tan 40. Okay, so anything tangent. Okay. So for these problems, guys, 10 through 18, you were implicitly expected to draw both special right triangles for this. Okay. So from here, and the reason why you're implicitly expected to do that is because then you can just refer to said triangle. So from here, each hypotenuse is 1. And so from here, with 45, 45, is everybody okay with this side being 1 over rad 2 and 1 over rad 2? In other words, can someone give me the rationalized version of the 1 over rad 2? Kendall? Rad 2 over 2s. And then across from the 30, how much is across from the 30 going to be? Kendall?
1.5. Oh wait, 0.5.
1/2, yeah, 1/2. There you go. And then across from the 60, can someone give me the length of across from the 60? Elena? 1/2 rad 3. Can I just put rad 3 over 2 instead? Cool. Let me guess. How did I get those? Okay. So remember that conversation we had about dividing by rad when you were It's the same idea. So so in order to move from leg to hypotenuse on a 45, 45, 90, you multiply by rad 2, right? Right? In order to go from hypotenuse down to leg, what do? Divide by rad 2. Yeah. And so from here, this is the same idea. Yeah, did 12, 15, and 18. They all revolve around both of these triangles.
Okay, well, is the top triangle just like a base?
It's a 45, 45, 90 right triangle, and all of them, all 45, 45, 90 right triangles are similar. So yes, it's a baseline one. Because they're asking me for angles that constitute 45 degrees, 60 degrees, and 90 degrees, and 30 degrees.
I don't know.
So are you solving all three problems at once?
Yes, I will.
Okay.
Yeah. So from here, Jansen, if they want me to use a 30, if they want me to take tangent at 30 degrees, which triangle are they asking me to reference? The bottom one. So that's going to be opposite over adjacent, right? So that's going to be 1/2 divided by rad 3 over 2. And then from here, the way I divide two fractions is 1/2 times 2 over rad 3. The 2's cancel each other out. I get 1 over rad 3.
Do we have directional like that?
Absolutely. So rad 3 over rad 3 becomes rad 3 over 3. And that becomes your answer. Jensen, you okay with that? Jackson. Give me 1 second. Jensen, you okay?
Yeah.
All right, now 60, which triangle am I going to look at?
15?
Yeah, 15. Tangent of 60.
The bottom one.
Bottom one. So again, opposite over adjacent, right? Tangent. So opposite over adjacent. Rad 3 over 2 divided by 1/2, which is going to be rad 3 over 2 times 2 over 1. The 2's cancel and you end up with just simply rad 3. And then tangent of 45, Jansen, which one is that going to be? Top one. So again, it doesn't matter which 45 I reference, they're all the same. So rad 2 over rad 2. And anything divided by itself, Jansen, is always 1. Jaden, talk to me. From that section? Sure. So sine of 30. Okay. So Jaden, which triangle am I referencing? Bottom one. So 30 degrees is here, opposite over hypotenuse. 1/2 over 1, but anything over 1 is always itself. So you are equal to just being 1/2. Nice. Jess?
Number 45.
45, sure. Okay, Jackson, great question. So this one again, this is one of those, order doesn't necessarily matter, but it kind of does if you want to make your life easier. Since they're all being multiplied. So Jackson, check it out. If I multiply this singular I in, and then I multiply these two binomial pieces together, I'm gonna end up with an I cubed. And that's nothing wrong with that, but I think, I think we can make our lives a little bit easier by just taking care of this guy first and then multiplying the negative I in after the fact. So I'm thinking 4 minus 2i plus 6i, and then minus 3i squared. So you see how one of the i's is going to go away because we have an I squared there? So and you just can't forget that there's a negative I hanging on the outside here. So that's going to become, looks like 4i positive with a 4 here, and that's going to become a plus 3 because I squared is -1. So these guys can now combine out to become 7 plus 4i times -i, and then you just distribute in. So you have -7i minus 4i squared, and then I squared is -1. So that becomes -7i plus 4, or 4 minus 7i. Good enough? Nicole? Sure. Ava, I've been ignoring you. You said you had a question a while back. Oh, you did? Okay, cool. Caleb.
Number 20, please.
20.
Yes.
Sure. Are they Pythagorean triples? Show your work to verify your answer. Oops, all right. 20. They give you 5, 10, and 12.
I know it's not one, but I don't know how to explain it.
Got it. 5 squared plus 10 squared does not equal 12 squared, right? Then that's how you do it. So 25 plus 100 does not equal 144. And that would be your proof. Good enough? Cool. Isabella, talk to me. 17. Okay, remember this diagram up here, Isabella? Cos 45. Which triangle am I referencing? Top one. So cos 45, cosine is what the ratio of what two sides? At this point, sine, cosine, and tangent should be. We need to have. That's okay. We need to have it as an automatic reflex. So can someone help us out here? What is cosine the ratio of? Landon. Adjacent over hypotenuse. So in this case, adjacent over hypotenuse would be rad 2 over 2. Jaden.
On the 45, is that side rad 2? And that side is rad 2?
No, they're both rad 2 over 2. Both of them.
Okay, so to go from
Mhm.
you divide them?
You divide by rad 2, yeah. That's why they initially started off as 1 over rad 2. Then you have to rationalize the denominator. So you get rad 2 on top, right? Over rad 2 times rad 2 is 2. You okay? Kendall.
I just wanted to check with you on, you know what? I don't need to.
Are you good?
Yes.
Cool. Sarah.
Can you do 57A and 59A?
57A and 59A. Yeah. Okay, so determine the measure of one exterior angle of the following regular polygons. So with A being a pentagon, so from here, pentagon, how many sides? 5. So you do 360 divided by 5, which is what? 72? Is it really?
Yeah.
Oh, good for it. Second? Is it 72?
Yeah.
Good for it. Okay, cool. Good guess. And then what is it? 59 who now? 59A. So find the area of the regular polygon if the length is one side. Okay. So 59A, Sarah, again, another pentagon, right? And it's a regular polygon, so we're going to figure out the measure of one. Oh, no, we're finding the area, sorry. So in this case, finding the area. So remember, the area, Sarah, is going to be 1/2 base times height times number of triangles. So in this case, they're saying that one side is 8 centimeters. So we can actually plug in 8 for the base already. We can also plug in 5 for the number of triangles, right? So I'm going to go and find out the area of one of those triangles. And the way I'm going to find the height for one of those triangles, right? So the way I do that is I have to figure out the measure of all the interior angles. So that's going to be 180 times 5 minus 2 over 5, right? That's going to be 108, right? But I'm going to chop that thing in half to get, what was that, 54? So that's going to be 54 right here, yeah? So now from here, if I split him down and I break him out, I'm going to get 54 degrees here. This 8 is going to become a 4, and I have to solve for the height. There's no special right triangle here, Sarah. So I'm going to have to use, looks like, angle, opposite, adjacent. Who can raise their hand and tell us what is the relationship that brings those guys together? Zoe? Costco. Jackson. Tangent. Tangent of 54 is going to equal h over 4. And now I multiply both sides by 4. And then I have 4 times tan 54 equals h. Now, Sarah, if you don't have a calculator on the midterm. And you're done. Actually, no, you're not, because you can divide those out. So that will become a 4. 4 times 4 is 16. 16 times 5 is 80. So 80 tan 54. And now you're done. Cool. Anything else? Any other questions?
Can you do 50?
Braden, 50? And then Sydney, I'll come to you next. Okay? Okay, just rewrite as a fractional exponent. Cool. So 50 is the 5th root of 3 to the 4th. So Braden, the way this works is the power is the numerator, the denominator is the root. So does it make sense that the 5 is the root? Or sorry, I mean the 5 is the denominator, sorry. Denominator. And then 4 is the numerator. So it's really just 3 to the 4/5 power. That's it. Cool?
Yeah.
Sydney, talk to me.
Can you do 60?
60. Which one?
Oh.
Why don't I do a couple of them? That way you can kind of struggle with it a little bit. All right, so from here, it says the ratio of similarity is 7 to 4, and the perimeter of figure A is 20 units. What's the perimeter of figure B? So 60A. So we know that the ratio of similarity is equal to 7/4. And we know that the perimeter of figure A, and it says use ratios in the form A over B, which means A is going to be the top guy, B is going to be the bottom guy. Okay, and they want us to do that every single time. So if I know that 7/4 is my ratio of similarity, and my perimeter is going to be something, I don't need to square anything, right, Sydney? Because they're not talking about ratio of areas. It's side length to perimeter, and those side ratios are always the same, right? So 7/4 is going to equal A over B, right? That like 7 is to A, 4 is to B.
Yeah.
But I already know the perimeter of figure A, right? Perimeter A is 20. So I can say 7/4 equals 20 over B. And I believe I can now cross multiply to get 7B equals 80. So divide by, 7, and B equals 80 over 7. Cool on? That's how you do the rest of them, except for like, if you look at B, it says the ratio of similarity is 1/6, but they give you the area of figure A. So this is the side scale factor. Sydney, what's the area scale factor? 1/6 squared. So that's 1/36. You okay? So then you do,
That's the area, or is that just the scale?
that's the scale factor. So the way you would do B is you do 1/36 is equal to, looks like 10 over B. And then you solve for B.
Got it. Okay.
Good enough?
Yeah.
Cool. Landon.
2 questions. One, can you put B is like equal to 1, or what? You not recommend?
B is equal to 1
Yeah.
in this problem?
Yeah.
Well, B would get multiplied by 1. B wouldn't be equal to 1. B would be equal to 360, if anything.
And my second question is, can you do question 48?
48. Sure. So from here, Landon, you've got the cube root of 49. So in this case, dude, I don't think there's any perfect cubes that go into 49. So I don't think we can simplify it at all. So the only thing you can do is convert it to a fractional exponent and call it 49 to the 1/3.
So how would you get that?
What do you mean? How would I get this? Well, remember the power is the numerator, right? And the root is the denominator. So just 49 to the power over root.
Okay. Thank you.
Kill?
51.
51. Okay. So from here, I hate you circled it on your packet here. So 51. So the cube root of 7 all squared. So I can see why this would be confusing. It's the parentheses, right? But that just means to square it after the fact. But if you square it after versus before, it actually doesn't change anything. It's still 7 to the 2/3 power.
Really?
Yep. You good?
Okay then.
Sarah, talk to me.
For that one, do you not square like the 7 to about 29 and then increase it?
I mean, you know what's funny, Sarah? If you do that, if you actually square the 7, then you're back at this problem, which again couldn't be simplified anyway. So there's no need to really square the 7 at all. Yeah. Jaden, talk to me. 25.
I have a question on this problem.
Yeah, talk to me.
It's about 48. So if it's just like simplify all the way, would we want to make 49 add 49 into 7?
No, it's fine. Because, and the reason why, Landon, is because they actually gave it to us 49. So there's no need, like, the word simplify means to have as few symbols as possible. So the difference between these two is actually negligible. There's nothing. It's a number being raised to a fractional exponent. That's all. Go.
So for number 23, sorry.
Yeah.
Are we going to be expected to compute that?
No.
on our own?
No, 7 to the 4th power would be unreasonable. So just call it the cube root of 7 to the 4th and you're done.
Okay.
Yeah, so you will not be expected to know 7 to the 4th power.
Wait, so it's just, you don't have to, it's just 3 divided 7 to the 4th power?
That's it. Yeah, that would be unreasonable for us to ask you to do that without a calculator. Jane, what am I doing for you? 25? So negative 8x to the positive 2/3 power. So the way I would do this one, Jaden, is I would actually split them up. I would call it negative 8 to the 2/3 times x to the 2/3. And this guy here, I would just call him the cube root of x squared. The x part's done. Now, this guy here, can we actually take the cube root of negative 8? And if we can, what is the result of the cube root of negative 8? Zoe? Negative 2. But he's still being what? Raised to the 2nd power. So what I got is 4 times the cube root of x squared. And then you're done. Yep. Everybody cool with that one? Sarah, what's up?
28?
25.
Wait, can you go over? Oh, never mind.
You good, Jensen?
Yeah.
City.
Why did you multiply 808 times x?
So remember how in the past we, like if I did like the square root of 48, I would make that the square root of 16 times the square root of 3. This is the same idea where basically because I've got a fractional exponent going on, there's a rad going on, right? Which means you can make this negative 8 to the 2/3 times x to the 2/3. It's the same principle as this.
Okay.
Yeah. So another way of looking at this is it would be like saying the cube root of negative 8x all squared, like that, right? So I could call it 3 cube root of negative 8x times negative 8x, right? Which would then be the cube root of that would be a positive 8x times the cube root of negative 8x, which is essentially this thing.
Okay, yeah. Okay, thank you.
Cool. Sarah,
It would be wrong to leave it as the cube root of negative 8.
because you can simplify the 8 part, yeah. So you could have done that, yeah. But if I jump for that straight ahead, people won't really know like what I did. Yeah, but if you did that on a quiz, I would be fine. Isabella, talk to me. 74. Oh, we're getting pretty far in the packet. That's good. Okay. Yeah. Sure. So with 74, Isabella, we've got. Oops, darn it. Looks kind of like that. So I'm seeing 1, 0. I'm seeing negative 5, 0. I'm seeing 0, negative 5. And I'm seeing negative 2, negative 9. Okay, so I got to write the equation in. Oh, by the way, did I tell you guys, please bypass 69 through 71. You guys haven't learned how to do that yet. 69 through 70. Yeah, sorry, Franklin. Yeah, bypass 69 through 71. You guys haven't learned how to do those yet.
So we will not, that will not be on the midterm.
It would be unfair to put those on the midterm. You guys have not learned those yet. So
Okay, you cross that those out for me.
sure, except my pen doesn't work on a regular platform. So no, you guys already know standard form. You guys are gonna learn. Yeah,
Right,
cross out.
hold on,
Yeah, thanks, man. You guys are gonna learn vertex form after the. You stained my table.
sorry.
Unacceptable.
Would that possibly be a bonus?
No, not even close, because I haven't taught it to you yet. Bonus problems are usually things that like extend from things that I've taught you. I haven't taught you this at all. So it would be unfair for me to ask you this in any form. 71.
71.
Yeah, because I haven't taught you guys about vertical compression and vertical stretch and stuff like that. So that, you know. Yes, but I haven't taught you like how it manifests. You know what I mean? And so, you know, I'll show it to you guys after the midterm. It's all good. All right, Isabella, check it out. We have not seen this in a long time. -5 is the 0. Can someone tell us what is the factor? What is the factor? Raise your hand and say, what is the factor? Howard. Everybody deal or no deal? Deal. Can someone tell us 1 is the 0? What is the factor? Nicole. Nicole, how are you? Good. Y equals, how am I doing? Bad. Why am I doing bad right now? Why am I doing bad? Kendall. Need to find A. So, what? By the way, what are you guys going to forget? We haven't done these problems in a long time. What are you guys going to forget on the midterm? Please don't forget. A. Don't forget A, okay? Of how could I, you know, Nicole, I would be irresponsible not to put one of those on the midterm. It would be irresponsible. Okay, so there you go. Ava. Yes. Now, actually, do I have a couple of different options of one I could plug in? Yeah, I could plug in 2, -9. Well, I don't want to plug in anything because some of them aren't really clear. But I have a choice between 0, -5 and -2, -9. Now, why is 0, -5 the more advantageous choice? Not that -2, -9 is bad, but why is 0, -5 the more advantageous choice? Nicole. Yeah, there's a 0. It makes life easier, I think. But if you want to challenge yourself, I'm fine with it. Oops, darn it. Mistake. It's not y equals. It should be -5 equals. -5 equals A, 0 plus 5, 0 minus 1. So what you got is A times -5 equals -5, divide by -5. And in this case, A equals 1, but I need you to show me that that's true. So then Y equals, now it does say right in standard form, which means we actually have to multiply this thing out. So X plus 5 times X minus 1. So Kendall, yes, there is this is what we call standard form. Yeah, but after the after we get back from the break, you guys are gonna learn something called vertex form.
Which break?
Thanksgiving. Yeah. Costco.
Can you go up to the 59?
Can I 59 is lost in like cyberspace, man. I deleted that thing a long time ago. But it's on a video, so if you want to fast forward to about, you know, maybe a little less than an hour in the class. Yeah. Is there anything else? Jaden, talk to me. 32. I believe we just did that one, right? 6i rad 2. $35. Okay, we are taking the square root of a negative. What is going to be involved in our answer when we take the square root of a negative? Landon. An I, right? So from here, square root of -1, square root of 200. Now from here, to break apart 200, I need two numbers, one that's a perfect score, one that's not. Elena. 102. So 102 here. So the square root of 100 is going to be 10. The square root of -1 is I, and then rad 2. Good enough? Elena, talk to me. It's not wrong, but it's one of those things where, you know, it's convention to write it as 10i. Yeah. Sure, 67, 68, and Caleb, you've been waiting patiently. I'll come to you next. Okay. And then Landon, what's up, man?
I have a question on this question. So for my numbers, I got 25 and 8 being 25 the perfect square. So how would you do that one?
Boom. So 5 rad 8. Got to break down the rad 8 one more time into rad 4 times rad 2. 4 becomes 2. 2 times 5 happens to be 10. Rad 2. Either way you cut it. Cool. Okay.
Well, one has the I and one doesn't.
Well, I mean, assuming that Landon had done the other part right. Yeah, that's good. Sorry, Elena, what am I doing for you again? Got it. Okay. Sectors. Here we go. 67. The area of a 60-degree sector is 12 pi square meters. Determine the radius of the circle. We want the exact answer. Okay, so Elena, they're asking us to work backwards this time, okay? So I know that the angle in question is 60 degrees. That's going to be divided by 360, right? Because that's the portion of the area, right? Times pi r squared, right? That's how I find the area of a sector is equal to 12 pi, right? This is the area that they told me that it was. So does it make sense? It's just the equation. Got to solve for r. So 60 over 160, I believe is 1/6. 1/6 pi times r squared equals 12 pi. I'm going to go and divide both sides by pi to crush out the pi's there. So 1/6 times r squared equals 12. Multiply both sides by 6. R squared equals 72. And Jaden, if you ever wanted to see number 32 again, it's pretty much this, except there's no I in it. So R is equal to the square root of 72. The square root of 72 can be broken down. Can someone give me the goodest combination of numbers that's going to make this happen? Howard, 36 and 2. So I get R equals 6 rad 2. Cool. Elena. That's cool. Same thing. 68. Zoe, what's happening? Isn't that what I just did? Zoe, how are you? Okay. 68, you said, Elena? The sector of a circle with a radius of 5 is 10 inches squared. What's the measure of its interior angle? Okay, so from here, it's going to be some theta over 360, right? Times pi r, so 5 squared equals 10 pi. Yeah. So that means theta over 360 times 25 pi equals 10 pi. Are we good? I'm going to go and divide by pi again just to get rid of the pi's. So I've got 25 over 360 times theta equals 10. So I'll go and multiply both sides by 360 over 25. So theta equals, so 10 over 25, that's going to be what? 2 and 5 there. So what's 360 divided by 5? 72? 72 times 2 is 144. Nicole?
Wait, so you multiply 5 over 5?
Yeah.
Why?
Because I have to reciprocate my 25 over 360 to cancel it out.
Well, what if you just do times 360 on both sides?
Sure. Okay, cool. I can do that.
Oh,
And then divide by 25? You mean multiplying by 360 over 25?
Okay, so
Yeah. Yeah, so it's the same thing except one less step. Jansen. Oh, sorry. Sorry, I thought it was a question about this. Different question? Landon about this or?
Can I go outside and do more?
Oh, go ahead. Yeah. Kill. Sorry.
37, 38, and 39.
Yes, got it. Okay. Sorry, I was looking at something else there. Okay, so 37. 4 over rad 3. Caleb, got to rationalize that denominator. Rad 3 over rad 3. 4 rad 3 over 3. And I feel like that's done.
Okay, got it.
All right, Caleb, rationalize that denominator for 38. What do I multiply the top and bottom by?
Rad 2.
Rad 2, that's right. So on bottom, I get 2. Now on top, Caleb, it's going to be a little more involved. I get 5 rad 2 minus 2 rad 12. Am I done? No, what should I do next? Zoe, simplify rad 12. That's going to be 4 and 3. So 2 rad 3. So what I get is 5 rad 2 minus, be careful, this 2 and this 2 interact to become what? 4 rad 3 over 2. And I would just leave him here. I could split it up into 5 rad 2 over 2 minus 4 rad 3 over 2 and simplify that. But there's really no point at the, because it's not like the 5 can simplify either. So I don't believe that's any more simplified than what I have right here. Jackson, give me 1 second. Let me. Kelly, you good?
I also asked for 39.
39. Okay. So, Sydney, what's up?
I have a question about that.
Yeah.
Wait, how do they get from 5 rad 2 minus 2 rad 2? Wait, 2 rad 12. Wait, where are we?
Okay, so from here on the side, I had to simplify the rad 12. So what I really have is 2 rad 12, right?
Yeah.
And if I break them up into 4 and 3, this guy becomes a 2, but he has to multiply in with that 2. 2 times 2 is 4. The rad 3 stays there.
Got it. Thank you.
Good enough? So say again. Oh, thank you. Thank you. I did my best. Rad 5 over 6, Caleb, is really rad 5 over rad 6. Does this look like a more familiar position? Can anyone tell us what am I going to multiply the top and bottom by? Rad 6. Rad 30 over 6. Now, true or false? You can simplify. You can simplify rad 30. You can simplify rad 30. True or false?
False.
False. You can't. As tempting as it is, you can't simplify it. So how did you know it was going to be false? Okay.
And because most of the true false questions you ask are actually false.
Are in fact false, right? Yeah. All right, Jackson, I believe we did 60A already. I think it was Sydney's question. We did. Remember, it was like 7 over 4 equals A over B. Costco, talk to me. 54. Okay, each interior angle of a regular polygon is 162. So 54. So Minu, the formula for the interior angle of a polygon is n minus 2 times 180 over n. And that's going to be 162. Kick him over. N minus 2 times 180 equals 162n. Distribute in 180n minus 360 equals 162n. Subtract 180n from either side. So you got negative 360 equals, what is that, negative 18? Divide by negative 18. Someone help, please. 20. Thank you, Zoe. Howard. Everyone, deal or no deal?
Deal.
I think that's a deal. Yeah. Sarah. Yes. Or 3/4. Yeah. Yeah. Zoe. Which one? No. Each interior angle is 162, which means we just found out that this thing has 20 sides. Yeah. Yeah. Ava. No. Let's do it. 66. A circle is inscribed in a square whose diagonal is 10 feet long. What is the area of the circle? Let me see here. Okay. So from here, the square has a diagonal. Okay. Really tough question here, okay? Okay. So from here, what I'm going to do, Ava, is I'm actually going to go ahead and draw the square again, okay? Now from here, guys, check it out. This problem is actually really interesting. The diagonal is 10 feet long. Is that very cool? Now from here, can someone tell me how much are the sides worth? Allie, give me the unsimplified version. 10 over rad 2. Can someone raise their hand and tell us how did Allie get that? Kendall.
She speed multiplied both sides of the fraction by rad 2.
So I want something more simple than that. More simple. Sarah. We got a 45, 45, 90 right triangle here. So Ava, oh, and by the way, so that makes this, Allie, did you say 5 rad 2? Okay, here's what I would unrecommend you guys doing. I would recommend for this problem that you do not rationalize the denominator just yet. Here's why, is because that means that the diameter is 10 over rad 2, right? Which means, what is the radius of this circle? What is the radius of the circle? Say again? The diameter is 10 over rad 2. This is actually a really good question. So what is, can someone raise their hand and tell us what is the radius of this circle here? Nicole.
10 over rad 2 divided by 2.
And what is that? 5 over rad 2. Okay, cool. Now, again, notice how I have not rationalized any denominators yet. There's a reason why. Because I'm about to find the area of the circle, right? The area is pi r squared. I end up squaring it anyway. Allie, you okay with that? So what I get is pi times 25 over 2, and I believe that is going to be your answer. Maybe okay?
Yeah.
Tough question. That's a good one. In fact, I would consider that one on par with that 16 to the negative 2/3. They're like more involved than you would think. Whew, that was kind of a little scary there. Landon.
So when you're finding like when you have the radius, you have to like, can't you just rationalize the denominators first before you divide by 2?
Again, I wouldn't, because so based on Allie's version of 5 rad 2 of the rationalized denominator, that makes this 2.5 rad 2. And then if you have to square 2.5 rad 2, it makes your life just that much more difficult. So that's why, like, and Landon, how did I know not to do that? I think I kind of got lucky on that one, you know, but if you don't rationalize the denominator, I saw this as, decimal, and I'm gonna end up having to square it. And so that's why I kind of just bypassed the whole rationalizing.
Another problem like that, and it doesn't automatically go to a decimal, it's gonna be that hard. I
think decimals are just hard to work with, but you know, there I said it for the whole world to hear. Yeah. Costco, talk to me. Oh, I'm sorry, go ahead. Yeah. Good question. Can someone raise their hand and answer that question? How do we get 10 rad 2 for the diameter? Jansen. 45, 45, 90 right triangle. Good job. Minnie, are you good, man? Okay. So from here, Minu, check it out. How much are each of the sides worth?
1 over rad 2.
How'd you get that so fast?
I divided it by rad 2.
Oh, you mean you took the hypotenuse and divided by rad 2? Oh, you mean like this is the hypotenuse and you divide it by rad 2? That's how we got that.
But then how does that apply to the diameter?
Got it. Because remember, the circle is inscribed in the square, right? So technically what you're looking at is you're looking at that image right there, right? And so since this is 10 over rad 2, it's got to be the same as the diameter, right?
Okay.
Cool. Okay. Lash, what's up, man? Yes. Nicole.
I have 2 questions. What would happen if it was a rectangle? Like, what if it wasn't an equilateral?
Like an equilateral rectangle, like a square?
Or, I mean, a square, yeah. Like, what if it wasn't a square?
Then technically the circle. Well, you couldn't inscribe a circle inside of a rectangle, right? Because a circle inscribed inside of a rectangle would be an oval, right? The notion of inscribed means touching the edges. So if I was to do a circle, they'd have to, well, it's not a bad question, Nicole. They'd have to give me some mechanism to figure out the height of the rectangle, which would then be which would be equivalent to the diameter of the circle. I'd have to have some mechanism for it.
Like we got this
because it was yeah. Yeah, you'd have there would have to be something like okay, what it would have to be something like, and I did a problem like this yesterday where they would talk about like the rectangle being a sheet of metal, and they would have to bend up each side at 30 degrees. So like, let's say they're creating a gutter, we'd have to know they were bending up each side at 30 degrees, and that would make this 30, which would then make this thing, well, let's say this was say 1, right? That would make this thing 1/2, and you would now know that the diameter was 1/2. They'd have to make the problem a little complicated that way. It's not undoable, but they'd have to specify that you were bending up the sides at 30 degrees to force you to do it 30, 60, 90.
Yeah, also, my second question is just,
Or sorry.
okay, does the final answer, also find this too?
So if you were to actually do it in a calculator, you would do 25 times pi, get a number, and then you would divide that number by 2.
Oh.
So the top and bottom are not both being multiplied by pi. Mhm.
So that the number doesn't apply to pi, it's just pi?
Well, technically pi over 1, right?
Oh.
Yeah. Howard, deal. Costco, what do you got?
60 CD.
Okay, can I do those tomorrow? Because we just did A and B today. I want you guys to struggle with these a little bit. I'll do C and D tomorrow. Yeah, say again?
You want us to suffer?
A little bit. I mean, I want you guys to try them out, you know? Yeah. Yeah, I did A and B already. So I want you guys, I mean, the midterm isn't tomorrow, right? And so if the midterm was tomorrow, I'd absolutely do it. Zoe, what am I doing? Who now? Oh, probably today.
I thought the answer sheet was on the, like, the midterm download.
Was it? It might have been attached. I don't
One of
know.
my outstretched last Saturday was.
Interesting. Okay, I'll have to check. How are we doing? How are we doing with questions? Jaden? I will, yeah. Sarah? At some point, yeah, hoping today. Pray. Okay. Okay, I guess I'll stop the recording. I'll let you guys work.
When are you a special agent?